Hi everyone, I'm Jeremy Arsenal, and I'll be presenting the Business Intelligence Team's Customer Propensity Model and Findings. Let's jump into the agenda. So today, I'll be walking you through the modeling process and some of the characteristics of the top 100 prospective customers that were identified in our model's predictions. The assigned task was to create a propensity model that could identify the top 100 most likely customers that would accept our new line of credit product offering. And through this process, we discovered some interesting customer profiles for our historical customers, as well as some similarities in the prospective customers chosen by the model. This presentation will cover the data overview, sampling techniques used to train the model selection process, and some insights on our historical customers and how they compare with the identified prospective customers. Here's an overview of some of the data variables that we use to build out our different testing models. We used data on 4,000 of our current customers to train these models. Data included a current customer list that had results on the most recent marketing offer, as well as past offers from our marketing department. Supplementary data tables were also used to enrich the data. These included customer data on sociodemographics, vehicle information, and creditworthiness. The data was fairly clean, with only past outcomes containing a high amount of NAs that led us to removing it from our analysis. We performed some feature engineering on the data, which included creating a new variable that measured call duration. But the majority of feature engineering and data cleaning was performed using a data modeling package called vtreat that added a multitude of additional variables that were used to train our models, which we found to be helpful and impactful. Here are a few high-level characteristics that were included in our sample data. As you can see, most of our customers fall in the middle age category, with the highest group in their 30s. We also looked at the overall distribution of car years for current customers and found that most cars were relatively new, with the majority purchased in the last 5 years. This was something we kept in mind when checking the predictions of our model, since the new line of credit will be backed by the customer's used car. Some other notable statistics from our data included that only 1% of our historical customers had a default on record, and on average, 40% had accepted the previous marketing offer. So now moving on to our data sampling techniques. In order to train our models, we broke out the data into 4 different sets. One set was used exclusively for variable treatment, which went into the vtreat process mentioned earlier. This represented 10% of the overall data. And of the remaining data, 70% was used for training our models, while 15% was used to validate the results to ensure models were not overfitted. And the final 15% was used to further test the chosen model to be certain it was still performing as expected. We then applied the prospective customer data to the chosen model, and customers with the 100 highest probabilities of accepting the new line of credit were then selected. So how did we select our final model? Well, first, we tested 3 different algorithms before selecting the appropriate one to use in our propensity model. The first was a logistic regression model, the next was a decision tree, and the third was a random forest model. We looked at multiple metrics for choosing the right model. These metrics included accuracy, sensitivity, precision, F1 scores, and area under the curve, or AUC. All 3 models had relatively similar performance metrics, but in the end, we decided on using the logistic regression model as it slightly out-edged the other 2 models in AUC. Plus, during the testing phase, it correctly predicted 81 out of 100 customers accepting offers, which aligns with its area under the curve score and is significantly higher than the average acceptance rate of 40% mentioned earlier. When looking at current customers that had accepted a loan offer, we found a major relationship between customers who accepted offers and how long they stayed on the phone with bankers. With customers who accepted offers spending on average about 9 minutes on the phone versus about 4 minutes for customers who declined the offer. This is not surprising, as we expect customers who are interested to ask more questions and hear out what our bankers are offering. So when bankers reach out to prospective customers, they can gauge interest and assess the likelihood of acceptance based on the duration of the customer's engagement on the phone. This insight can streamline subsequent mailing efforts by prioritizing calls before sending mail, which will ultimately save time and resources. Other interesting insights we observed among current customers who had accepted previous offers were the influence of home insurance ownership and outstanding car loans. We found that 50% of current customers who did not have home insurance accepted our latest offering, versus only a 30% acceptance rate for those that did not have home insurance. And we believe that there is some merit to this, since about 7.4% of all homeowners in the U.S. are uninsured. And for those earning under $50,000 a year, this amount doubles. So these customers may need additional funds to cover unexpected expenses that would normally be covered by home insurance. We also thought it was important to look at customers who had outstanding debt on their cars, since their car will be used as collateral for the loan. And in the event of a default, it would be preferable to avoid disputes with other lien holders who may have claims in the car title. Our findings show that customers were more likely to accept an offering if they did not have a car loan, with 42% of customers accepting an offer with no outstanding car debt, versus 29% of acceptors who did have an outstanding vehicle loan. And as we will see in our next slide, this aligns with attributes in the prospective customer list. So I want to give some background on how our top prospective customer profiles, which you can refer to in the provided handout, compare to our historical customer profiles just mentioned. One key characteristic is 0 of the proposed customers have had credit defaults on record, which is a good sign for loan repayment. Additionally, the majority of their cars have been bought in the last decade, with the highest proportion being purchased in the last 5 years, which should increase collateral value and therefore loan amounts. And staying on the topic of cars, almost 100% of the identified customer targets do not have a car loan, which means they should own their car outright and reduces the risk of having issues obtaining title in case of a default. And finally, like we saw with our historical loan acceptors, the majority of these potential customers do not have home insurance, which historically has been a strong indicator of accepting previous offers. To wrap things up, our model has identified 100 prospective customers that have the highest likelihood of accepting the latest credit line offering. The chosen model has about a 76% probability of correctly identifying a customer that will accept the offering, which is significantly higher than the 40% historical average of customers accepting a previous offering from the bank. These customers share similar qualities with our historical customers, with some of the most important being that they own relatively newer cars, have no car debt, and are creditworthy with no defaults on record. Bankers who call these prospective customers should be aware of average call durations to get a sense if customers are likely to accept an offer once it is mailed to them. This additional data could help corroborate the predictions of the model. And with that, this concludes our findings. Thank you for your time, and please let me know if you have any questions.